Okay. So Shubham Kadam.
Yes, sir.
Yeah, there's a lot of noise from your mic, huh? Can you mute the mic? Yes.
Sorry, sir. Sorry.
Everybody, please keep your mic muted. Okay, and all this is going on record, so be careful. Huh? I know, I mean, everybody is normal, but don't try to play any mischiefs because we are able to make out who is doing what. Okay, so okay, let's go back to the PPT. Okay, you can note down this YouTube link so that you can watch this movie later on, whenever you're free. But great circle sailing. Now, as we studied this spherical triangles, we saw that what exactly is a great circle. Okay, and between any 2 points on the surface of the earth, if we go along a great circle, that will be the shortest distance. You can actually take a ball, a big size ball, and just try to draw a line on that, or between any 2 points. You will see, if that plane is going through the center of that sphere, that is the shortest distance. Okay, so remember, the shortest distance between any 2 points is the distance along a straight line between them. That is on a normal plane, the surface. And but on the surface of the sphere, we cannot have a line, straight line. It will be curved. If you try to draw a line between any 2 points, it will be a arc of a circle, for which we the of the sphere. Okay. So that Sohail, what happened to Sohail, Mr. 1508? A great circle, by definition, has a radius equal to the radius of the sphere, and therefore it has the largest possible radius of that sphere. The shortest distance between any 2 points on the Earth's surface is the shorter arc of the great circle passing through those points. And by sailing along a great circle track, a considerable saving distance is obtained as compared to the sailing between the same 2 points. So, like if you are on a 15 or 20 days passage, you will be almost sailing 1 day's passage. You can contact Mr. Sohail 1508. Okay, why he has left the conversation on, why he has left the meeting or the class. I would like to know that. And it is going on the record. Okay, I will just put a message also later on. Now, the saving is greatest when the positions are east or west, because the savings are greatest when the positions are east and west of each other, and least when they are north and south of each other. Okay, because when you're going north and south on a great circle track, that is also a rhumb-line track. So whether you're basically, although you may be on the rhumb-line, but it is also a great circle track. So there is no saving as such, So that's why I put some questions in the multiple choice. Like let's say if you're going from, or if you're on the same meridian, let's say 40 degrees and 160 south, and again 40 degrees south and same longitude, you will be sailing along a great circle, and also that will also be a rhumb-line track, and there will be no distance, saving in the distance as such. Whatever the course, the saving in distance would be greater in higher latitudes and least at the equator. Okay. Because see, you just try to imagine on a sphere, that departure is, although you're crossing the same longitudes, but the departure is the least near the poles. Departure is equal to d long into cos m lag. Or if you're on the same latitude, we can say it's equal to cos lag. So departure is equal to cos lag. Okay, if you are going along the same parallel of latitude. So that's why if you try to go on a northern path, then you will be saving quite a bit of distance. Okay, and you will be covering up a lot of longitudes. So thus a maximum saving in distance achieved when sailing east or west in high latitude. In practice, sailing exactly along a great circle track is impossible. It's a fact. It is, we cannot practically, then we may not be fulfilling some criteria. Like I told you, almost 30 years ago, we actually sailed, just by following the GPS. Whatever the GPS was showing, like go on this course. If you are, we can set the GPS to whatever we want, in the sense whether to show us a great circle track or whether it to show us a rum line track. So it kept showing us a great circle track, whatever the course, and we kept following it. But in today's time, we cannot do that, because everything must be already planned, in the sense that it must be noted down also what course you are following, for the whole voyage. So nowadays maybe they will not allow that, but earlier I've done it. You can just put it on the GPS and keep altering what GPS tells you. So we had to keep altering, after every 4 hours something, maybe 1 degree or half, or 2 degrees, like that. Okay. A vessel may, however, sail along a series of short rum lines between successive points on the great circle track. And that is what we do actually. We first draw a great circle track on a mnemonic chart. Let's say if we are going from Gibraltar to New York, on a mnemonic chart, we just draw a straight line, connecting the Gibraltar and the New York. And then from that track, you can pick up some convenient points. Let's say if your speed is 14 knots in 24 hours, tell me how much distance you will cover in 24 hours if you are doing at 14 knots. Just calculate quickly and put in the chat. What happened? Very slow. In practical navigation, sit down with a notebook and your scientific calculator. Okay. I still don't see any answer.
Sir, I cannot see the PPT.
Then the problem, who is that?
1522.
Yeah, what's your name?
Pawan Dixit.
Pawan Dikshit. Where are you staying, in Nava?
Yes, sir.
Yeah. So I think the problem is in Nava at your end, because see, if I am sharing the PPT, and let's say even 5 people are able to see and rest are not able to see, that is the problem is at their end or their internet. So that is the problem. Okay. You can report this matter to the course in charge, that I'm not able to see or whatever. Okay. Yeah, what happened? Yeah, I'm still not able to see any answers on that. Pawan, is your video on?
No, sir.
Okay. Just can you share your, just take a screenshot and send it to me and the course in charge. Let's see. What happened? Nobody has been able to calculate. Now I'm getting some answers. 336, 14 knots. Yeah, who is that? Sahil, 1526. Only one answer so far. I think maybe I'll have to, practice your calculation then with the scientific calculator. Huh? From tomorrow's lecture, be careful. Huh? You must give the answers. Okay. So the idea is why I asked you to calculate, so that On the great circle track, we can approximately take this distance, 300 or 350 miles, so that, and those we can pick up those points and then transfer those points onto the this Mercator chart. Why I'm saying this one day? Because so that you will only be altering, every noon, or say let's say morning 9 o'clock or 10 o'clock. The master can decide, okay, let's make the point such a way that the alteration is happening in the morning time, 10 o'clock or 12 o'clock or whatever. Okay, so that is the idea of calculation, that we should be able to calculate, like we will be altering, let's say every 12 hours or 24 hours or whatever, depending on the plan of the master. Okay, so basically the points will be picked up from that great circle track that is laid out on the mnemonic chart, and then those coordinates, the lat long, then those will be plotted onto the Mercator chart and joined, so that the vessel can now follow the rump line on the Mercator chart. Now, in solving a great circle sailing problem, the spherical triangle to be solved is formed with one side as a great circle track and the other side will be the meridian. So like we are always, by looking at those three pictures, it is a little light. In fact, you will be able to see that how we are going to be calculating the course and all. You should be able to visualize or draw the meridians so that we are able to calculate the distance, the course. Let's say like in this third one, you can see my cursor, no? What I'm moving.
Yes, sir.
Yeah. Okay. So like, see, in this case, in this third figure, this angle, what it is making with the meridian is this one, what is already shown there. Okay. But let's say if I have to measure the other angle, if I have to see this, I could be measuring this as angle also, depending on what is the initial course I'm trying to calculate or the final course. So basically, the angle will always be formed with the meridian, and we'll have to see which angle we are calculating. So accordingly, we can, apply those north, south, east, west things so that we get to the correct quadrant. But as I told you, when we are using the ABC tables, that problem is not faced, and we can immediately know, what should be the course. Okay, in the three-figure notation. Like, we although we get the answers in the quadrantal form, but we are easily able to convert if we are using the ABC tables, like what will be the course. Okay, but if you're using this cost formulas for calculating course and all, then this you have to remember and you have to see what will be the course, whether it will be, the final course is 045 or it is 135. Okay, the great circle track between two positions in the same hemisphere will curve towards the pole of that hemisphere. Okay, so let's say if you are going from, let's say 40-degree north from 050 east to 150 east. So the great circle track, it will be curving up towards the pole of that hemisphere. That means when you see on the this Mercator chart, you will be seeing that if you draw that course line, it will be, the curvature will be towards the pole. Okay, so that is what it means, that the great circle track between two positions in the same hemisphere. So if the positions are both in the northern hemisphere, then the curve will be towards the north pole, and if the positions are both in the southern hemisphere, then the curve will be towards the south pole. Just remember this, because some of you were making this mistakes when we are doing in the class. Which side will the curvature be? Because when you're drawing those figures and calculating the values of, from pole to A or pole to B, this fundamental principle will come into play. Like which is the pole, whether it is the North Pole or the South Pole. Okay. So that's why this is important. Now, this third point, when sailing between two positions on the same latitude, actually equal or same latitude, in different hemisphere, the initial course will be equal to the final course. Okay. That means, let's say if you're going from 40° north to 40° south. So whatever is your initial course, if it is, because it will be mostly in the southern hemisphere, south quadrant, because your daylight is south. Okay. So what they are saying, if it is in 135, the final also will be 135. In other words, the inner angle at the departure position will be the supplement of the inner angle. Basically, the angles will be same. Practically, when you do it or when you draw a figure, you will be able to understand it much better. Okay. So you can take a snapshot if you don't have the PPT and just draw, just draw the figures, take two positions, same latitude, but on different hemisphere. And you see how the courses will look. Now okay, let's go through the theory part so that, tomorrow we can start to calculate and I'll give you those formulas. The vertex of the great circle is the point at which the great circle is nearest to the geographical pole. That is the point at which it is reaching the maximum latitude. Otherwise, also, somebody says that they have reached the vertex, that means they have reached the highest point. So, on course, like initially, let's say if you're going in the northern hemisphere, initially you'll be, going towards the pole, but when you reach the vertex, so no more further increase in your latitude. From that point, you will actually start descending, okay, or your latitude will start to reduce. Okay, so that is the vertex is the point at which the vessel's course is at the maximum latitude. Every great circle has two vertices, one in each hemisphere. If you draw a circle, you will see. You just on a ball, on a big, basketball or football, just try that. Okay, you draw any line and you see that it will have two vertices, one in each hemisphere. The only thing is, but of course, if the vessel is, let's say, in the northern hemisphere, we are not concerned with the other vertices, so we just disregard it when we are calculating. But in reality, the great circle will always have two vertices. Yeah, in the solution of the great circle, we are only concerned with the vertex which is closest to the arc forming the great circle. Now, it should be noted at the vertex, a great circle track will be exactly east-west. Okay, because the track, when you initially start, it is normally, let's say northeast or southeast or northwest or southwest. But when the vessel is reached its vertex, then it is at that particular point, only at that particular point, it is exactly east or west. It could be 090 or it could be 270. Okay. Every great circle will intersect the equator at 2 points, 180° apart. That's why we have those two vertices. The angle at which the great circle intersects the equator will be equal to the latitude of the vertices. Okay, let's not go into that. Okay, then this is a very simple thing. Like if you're on the same latitude, 40° north, if both the positions, that starting initial position and the final position are on the same latitude, then there will be an isosceles triangle, so that don't make a mistake. Like when you're calculating that distance from pole to the initial point and pole to that final destination point, that those angles will be same. If you're on the same latitude, so while calculating, we can easily find out. Okay, where only the initial and final courses are required, they may be found with reasonable accuracy by use of ABC tables, which we have done, and I'm sure you people should be able to solve that without any problem, because we did quite a bit of them in the class, so there shouldn't be any problem. However, where the position of the vertex and the position of intermediate points along the great circle track are also required to be calculated, the error which may result from using ABC table for obtaining the initial would be cumulative, and therefore that method of finding the course would be unacceptable. Okay. So if you're only trying to find the initial course and final course, then of course we can use the ABC tables. But if we also need what are the the intermediate points, that means what are the coordinates of the intermediate points? There are programmable calculators by which you just enter the longitude. It will tell you for a grid circle. Let's say if you have put the initial start position and the destination point, so it is telling you the initial course, and then you put like at what longitude you want, what will be the latitude of that course. So it will give you so that it becomes much easier for you to plot the course on the Mercator chart. Okay. So for the gray circle course, it will give you what will be the points on the Mercator chart to plot, or for those longitudes. And that is the time we cannot use the ABC tables. ABC tables is only good for calculation of initial and final course. But nowadays, of course, everything is available on with the help of the scientific calculators. You can easily calculate everything. And with the programmable computers, of course, or or the normal computer that you have on the ship, on the bridge, you have to only just input the starting position and the destination position, and it will tell you everything. To find the initial course, I told you, like, I will not go into this. And okay, does anyone have any doubt or problem in using ABC tables or calculation of initial course by using this ABC tables? Please ask me now. Or is everybody clear? If you know how to calculate initial course and final course using ABC tables, just write down in the chat, yes, I know. Okay. Just quickly write in the chat that you know how to calculate the initial course and final course using ABC. Yeah, that's good. I can see now some chats. Who that? Siddesh Desai, Sahil, Ritik Sharma. Okay. Okay. Anybody has any problem, so that I will explain in case there is somebody who is not able to understand, like how to using those ABC tables. So I will explain that again. Or in fact, one more thing is I will give you my number also. In case anytime you have any difficulty, you can contact me on that mobile number also. Okay, I'm just writing my mobile number. Okay, but this is not my WhatsApp number. Okay, my WhatsApp number probably you can see in the group itself. So, but if you have to call, you have to call on this number. Okay, otherwise, of course, you can send me a WhatsApp message using the number that is shown on that in the WhatsApp group of your classes, batch 15. Okay, so does anyone have any? I see nobody has got any problem with the ABC tables for calculation of initial and final course. So tomorrow, what we will do, I will start with the calculation of vertex. Okay. Okay. Has everybody understood what is vertex? Just say yes or no in the chat. Sahil says yes. Yes. Okay. Yeah, I'm getting a lot of yes. So I believe, or I can assume safely that So everybody understands at least what is the vertex. So what we'll do tomorrow, we'll start to calculate how to calculate the vertex. Okay. Any questions you people have for me?
No, sir.
Hmm? Yes. Any questions?
No, sir.
Okay. Okay. You know this. I'm seeing few names like this Love Prajapati. I don't know what it is. At 1P or IP or something. Shivam Panse also is showing the same name. 1P on the side. That is your initials. Siddharth Patil also. Why is that so? Okay, I will take a picture and I'll put it in the group because I want to know why this is being showing like this, you know. Okay, so nothing else to discuss for today. What happened? Nobody is there?
Yes, sir.
Hmm?
Yes, sir.
Yeah, okay. Anyway, we still
Yes, sir.
have some time left. So just go through those topics of vertex. And I mean, what I see from the chat that everybody at least understands what is the concept of the vertex. And then we'll see tomorrow how to calculate it. And be ready with your, the paper, pen and the paper, and also with the scientific calculator, and mostly every day whenever I have some lecture or otherwise also, I'll keep giving you some questions for calculation so that, you can do it and you can get the speed for calculation. Okay. So that is all from my side today. And in case you have something, you can ask. Otherwise, I'll be seeing you tomorrow. I think I have 3 lectures with you in the week, this week, and we'll go along with that. Okay.
Yes, sir.
Yeah.
Thank you, sir.
Yeah. Okay, then you can. I'll be stopping the recording and I'll be, disconnecting, ending the meeting also for everybody. Okay, then bye and see you tomorrow. Good luck for the day. Have a good day, you all.
Thank you, sir.